Welcome, this is Lab 3 for CE 260. We're going to be looking at application of Darcy's Law to porous media, and in particular we're going to be looking at calculation of what's called hydraulic conductivity, which is a measure of the flow rate of water, the flow of water through porous media in the subsurface, in aquifers, or in other types of porous media, like sand in a constant head permeometer. So what we have for our setup here is we have a little column here of sand. We have a funnel, we have a tube here, we're going to be pouring water into this funnel. The water is going to flow down. We're going to measure, we should know the heights that the water is flowing. That's the head that the water is at. So it's going to flow down through the tube, it's going to flow through this little device here, which is a constant head permeometer. In this device, what we have is just sand. This is grated sand. We could use other material, other granular media as well. We have this open right now. The water is going to flow through this device, this constant head permeometer, and then into the floor drain. What we're going to do is we're just going to keep a constant flow rate, a constant head driving water through this system, and then we're going to measure the flow rate of water coming out the other end. And that's basically all we have to do. If we measure the height, the head of the water, and the flow rate, and we know the cross-sectional area of the column, then we have enough information to calculate the hydraulic conductivity. So let's do this. In practice, we would have a pump. So we would have something that would supply a constant flow rate, and therefore a constant head to the column. In this lab, just for simplicity, we're just going to pour the water in and keep it at a constant level in this funnel, and so keep a constant head going through the permeometer. All right, so now we are just capturing, we're collecting the water that's coming out. So we're going to time the amount of seconds that pass while we're collecting volume here. We're just going to measure the volume that we collect coming out of this column. From there, we can easily calculate flow rates and look at Darcy's Law. If you look at your handouts, you can then easily back calculate the hydraulic conductivity. We're going to repeat this experiment at 3 different heights of our funnel, so 3 different total heads, and from there we can calculate hydraulic conductivities, which should be the same theoretically. We're going to see if that actually turns out to be the case in your experiment. So we've done this for you. We've posted the data on Google Sheets, and it's your job now to analyze that data and let us know what you find.